Okay, so in this video we're going to write a standard form polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. And we're now on number 16, and we've got x equals plus and minus 2 each, though, and that each is important, with multiplicity of 2. So each of these is a double root, which means our factor of x plus 2 is going to be squared because that's a double root, and our factor of x minus 2 will also be squared since that's a double root as well. Okay, then these are a difference of squares, and there's two of them, right? So when I do my difference of squares shortcut, right, my x plus 2, x minus 2, that's my difference of squares, I end up with an x squared minus 4. But because there's multiplicity of 2 here on these, I'm going to have 2 of those. So x squared minus 4, right, times another x squared minus 4, right, because of the multiplicity 2. Okay, now that is a binomial times a binomial, so when I go to expand that, I'll distribute, and x squared times x squared is x to the 4th. Then I have x squared times negative 4, so minus 4x squared. Then I have a negative 4 times x squared, so another negative 4x squared. And then negative 4 times negative 4 is a positive 16. Okay, when we combine our like terms, then in the middle, we'll have an x to the 4th minus 8x squared, and then plus 16 in standard form. Okay, now in example 17, I've got a 0 here at x equals negative 1, so that corresponds to a factor of x plus 1. And then x equals plus or minus I over 5. And I is the imaginary number, the square root of negative 1. So I have a factor of x plus I over 5 and x minus I over 5. Okay, now generally we don't write them in a fraction like that. So instead, if you think about it this way, because it'll be a little easier not to have to do that fraction. If you think about this 0 of x equals I over 5, right? If I multiplied both sides by 5, I could get rid of that fraction, and then I would have 5x equals I, and then to set that equal to 0, that would be 5x minus I equals 0, and 5x minus I then would be my factor. And that's easier to FOIL than it is to have this fraction here, the I over 5. So I'm going to write it that way instead so that I have nicer coefficients. So 5x minus I and 5x plus I. Oops. Wrong sign. There we go. 5x minus I. Okay, and these are a difference of squares here on the end. And so I can use that difference of squares shortcut to FOIL those out completely. So square the first term. 5x times 5x is 25x squared. And then minus, and I square the last term. I times I is I squared. But I squared, if you recall, is negative 1. And so a minus a negative 1 would make this plus 1. And I have 25x squared plus 1 for that difference of squares. So now I have a binomial times another binomial. I can FOIL those. So x times 25x squared is 25x to the 3rd power. Then x times 1 is a plus x. Then we have 1 times 25x squared is a plus 25x squared. And then our constants, 1 times 1 is plus 1. And to put this into standard form, we want decreasing order of exponents. So our cubic term comes first, 25x cubed. Then our quadratic term, 25x squared, then the linear, and then the constant. And so y equals 25x cubed plus 25x squared plus x plus 1 would be the polynomial in standard form.